Hey everybody, this is Todd Frazee, and this is going to be a lesson on Fusion 360 to machine the part for the TCOSE assembly, part number 5. The thing we're going to do, preparing the model file for a command we're going to be using. So let's first open up our part in design mode. Now the command I'm going to teach you how to use here to machine this part, machining strategy, is called 2D adaptive clearing. So it'll take the entire model and process what material needs to be removed. Now in this case we're going to start off with a rectangular or square larger piece, and we don't want to waste a lot of time machining away that entire square, but we want to contain it to a circular shape that's an offset of the diameter of the part, and that way it'll rough away all the material within that circle. So to give a reference for that circle, we're going to create a sketch. Go to Sketch, select on the bottom surface of the part, and then we're going to use the Sketch Offset command, which is this one here. And we're going to select on the outside edge of the part, and we're going to offset that 4 millimeters. We're going to use an 1/8 inch end mill, which is slightly over 3 millimeters. So that should give enough room for that cutter to cut within this space. Okay, and you're going to select OK. And we'll finish sketch. You can either press finish sketch here or here. Now we're ready to go into the programming side, which is in the manufacturer workspace. Let's close the data panel so we have a little more menu bar space, and we're going to switch from design to manufacture. And we want to make sure that we're in inches because we're programming machines that run an inch with inch tools. Our model was drawn in metric, but it will convert them. Alright, so we're going to first, like we have done before, you're going to do your setup for the material. So we're going to press Setup, New Setup, and it's going to put a rectangular volume around the part. And we want to change the orientation of the axis of the machine. So this was modeled so Z was going off in this direction. We don't want it on model orientation, so we're going to do a Select Z-axis plane. And so we are going to select the top of the part as our Z-axis plane. Now, because this is a completely round part, it really doesn't matter which way X and Y is pointing, provided we set it up in the machine the same way that we've set up. Now, our origin, I'm going to put it on the top left corner. It could be fine being in the center, but you select stock box point and then pick the white point on the left corner. So this puts our x-axis operator, this is right to left, y would be away from or towards the operator, and z is pointing towards the spindle. Now let's adjust our stock size. We're going to the stock tab. Now our stock offset on the sides, we're going to bump this up to a 1/2 inch, and then we're going to go down, and our top offset is going to be 0. So we're going to start off with a piece of brass or bronze that's 3 millimeters thick. We should be able to buy that in metric, and that'll save us time not having to machine the material down to thickness. So we go back to our setup tab. Our origin should still be the top left corner, but it moved out to the edge of the material. And our stock size is approximately 1.5 inches. It's a little bit more than that. Now let's go to our post-process tab, and we're going to put in a numbering convention that follows the number of the part. So we're going to do a number. The first 2 digits will be the dash number of the part, which is 05, and then this will be program 1. So 01. Then we're going to put in a program comment, which will be the name of the program. It'll show up on the setup sheet. Let's call it Operation 1, and we're going to use work coordinate system offset 1. So to review on setup, we should have top left corner, Z pointing up, X pointing horizontally along this edge. And our stock should have a 1/2 inch on the sides and 0 in all these other boxes. And our post process should be number 0501 operation 1 with work coordinate system 1. And we're done with that step, and our setup will show up over here on the left. Okay, so now we're going to apply the 2D adaptive tool. Now this is really effective for real complex geometries. This is a fairly simple part, but it has enough features that we can use this command on it. So select 2D adaptive clearing, and it's going to start with what tool to select. We're going to select the TCOSE library, and then we're going to select tool number 17, which is the 1/8 inch flat end mill. And select OK. And we're going to go 5,000 RPM. And our cutting feed rate, it should auto-populate already at the feeds and speeds that Kennametal recommended on the conservative side. Kennametal says you can run this much faster in feed rate, but we don't have a machine that has a high enough spindle RPM for it. So it's proportional to the feed rate. We could go up to 8,000 RPM on our machines, but for this academic class, we're going to go 5,000. Okay, so all of these should be at default. Your ramp rates and plunge rates, general rule, will be half of what your other feed rates are. Okay, we're going to go to geometry, and we're going to select the outside of the part itself. We're going to offset. We're going to select this boss flange. And then we're going to select this inside edge here. And we need to check that the arrows are on the correct side of the line. Now, this last one is not, so we're going to pick on there. You want the arrow where the material is going to be removed. Okay. All right. Now on this one, it's different than what you've done before. We're not going to use the stock for the stock contours. We're going to select the stock contour. And we're going to select this sketch that we've made. And that'll contain the machining to within that boundary. Our lead-ins will still want to lead in from outside the material. Okay, so now let's move on to the next tab. Heights. We'll leave these all at default. And we're going to machine to the selected contours. That's how deep we're going to go, but we're going to leave some material at the bottom. We don't want to completely remove this from the part material, so we're going to leave 0.01 on the bottom contour. And that'll leave some flash at the bottom that will cut through, or, well, in some cases we'll cut through like in the hole. But we'll probably leave a very thin layer of flash here to keep this part connected to the surrounding material while it's being machined. Okay, we're going to go to passes. We're going to leave these all at default. We're going to let the optimal load auto calculate. We do want a climb cut. We are going to cut at multiple depths. Our maximum roughing step down is going to be 0.05. I'm sorry, 0.06. So it's roughly half the diameter of this cutter. We're going to go in order by depth. And the stock to leave, we want to leave a little less than that. This is a little tiny part, so we're going to leave 10 thousandths radially and axial. So this is just purely roughing. We're going to come back and finish every surface on this part. Alright, because this is roughing, we can skip the smoothing and we're going to go to linking tab. We're going to leave all of these boxes at default. And then our horizontal lead in and vertical lead in and out. So on horizontal lead in, we're gonna bump that up to 7, a little over half the diameter of the cutter. For this, we're not going to do any fancy ramping, so we're going to do a plunge straight down. And the 3-foot cutter is center cutting, and this is a fairly soft material. Our ramped clearance height, we're going to set that at 0.01 is fine, and then we'll select OK. So as you see, we have a vertical lead in and a horizontal lead in, and it arcs in, and it's removing all the material, starting with this circle as the edge, and then it's going to do it in a couple steps on the outside and several steps on the inside. And if we look at the side view, we should be not cutting all the way to the bottom. So we've roughed away most of the material. Now let's simulate what we've done so far. So we highlight that operation, and then we're going to go to simulate. And for this one, I'm going to hide the holder, just because the holder is so big in relationship to the part, you won't be able to see anything. Okay, and we're going to display the stock. So we have it coming in, arcing in. It's spiraling towards the center. It's now going to pick up, and it should plunge in the same area to do its second clearing. And now it mills out the center, and now it's going to go around the outside periphery. Okay. The reason it went back to the center zone is we selected that box that says finish by depth. So it's finishing everything to a single depth, and then it comes back and does a center. Now you notice these facets. These facets are going to show up in the part, but it's roughing. And the machine will run a little faster, but it's broken the arcs into line segments. Had we selected that smoothing option, this would have cut a more smooth circle. It's going to be critical that we have the smoothing option selected when we do our finish cutting. Okay, so we've cleared all the material out of the way. Let's hit OK. All right. So to do our finishing, we need to finish this surface. We need to finish the inside diameter, and we need to finish this outside diameter. They all have 10/1000ths of extra material on them. First, we'll clean up this face here. So we're going to go and use a 2D contour command. We're going to continue to use that 1/8 inch end mill. And we're going to cut up to this boss feature here. So we're going to select the bottom of the boss. Make sure the arrow is on the correct side of the boss. And now we are going to leave everything on the first tab as is. Same RPMs and feeds and speeds. Our geometry, all we need is that circle. We're going to move on to heights. We'll leave all of these at default because we're going to cut down to our selected contour. Okay. On the passes tab, we're gonna come down these. We have tolerance, we'll leave alone. Sideways compensation, yes, we want to climb mill to the left. We do want to select this cutter compensation type wear. That allows the code to be output so the person operating can adjust the diameter of the tool based off the wear of the diameter of the tool. Okay, so we're going to keep continuing down. Our finish feed rate, we're going to go the same speed as our roughing rate. And finishing overlap, we're not going to worry about that. And lead in end distance, we want it to do a full lead in, so we don't want to change that. We're going to skip down to rough passes. These are horizontally. Now this flange is wider than an 1/8 inch. So we want to go around multiple times so that we're cleaning up the bottom of the part, the entire face. So we're going to do a maximum step over of 80% the diameter of the cutter. So let's get our calculator out. And we're going to take 0.125, which is the diameter of the cutter, and multiply that by 0.8, 80%, which gives us a value of 0.1. Okay, so we're going to put 0.1. 0.1 is a good number. 80%, if you're doing pocketing, it'll assure that you have full cleanup every time it changes directions. Our smoothing deviation, we're going to leave it 4/1000ths for the roughing cut, but the number of step overs we're going to do, we're going to do 2. So as soon as we check this box, a box appears up here, and it's our finishing step overs. It's a little confusing why they designed it this way, I don't know, but we do want to do a finishing step over of 0.005. Okay, and so what it's going to do is it's going to go around and rough and leave 5/1000ths for a final pass on this side step over. But that box doesn't appear until you check this box here, so you have to kind of go back and forth. Okay, we're going to go to linking tab, and on the linking tab we'll leave all this at default. We're going to do a horizontal lead in. I think we need to mimic what we did before, so we did a 70/1000ths lead in, and our sweep angle, we'll leave it at 90, and we're going to do 0.07 or 70/1000ths, and our vertical lead in, we're going to set it 0. We're going to leave these 2 boxes checked. If they're not already checked, you need to check them. This lead out, we're going to do a lead out, and it's going to be the same length as a lead in. We're not going to do a ramp, and that's done with our parameters. We'll select OK. So we have our one plunge, our first plunge, and it does one roughing pass. It does kind of a curved cut, comes in and does another rough cut, and then it picks up and does another arc in and arc out for the finish cut. Our next operation is to do another 2D contour. So here I'm going to show you something kind of neat on here. Is we like the parameters we have here for the most part. So we're going to right click on this routine, and we're going to do a copy, and we're going to do a paste. So now we have a copy of that same toolpath. Now let's go in and edit that toolpath. We're going to use all the RPMs that are the same. Those worked before. Our geometry is going to be different, so you're going to clear that out. And we're going to select the center bore of this part. And we need to pick on the arrow to put it on the correct side of the line. Okay, then we can go to the next tab, which is our heights, and we're going to leave all these at default. For this center bore, we're going to go ahead and cut all the way down to the bottom. And we should be able to leave all of these at default, except for we're going to just do 1. And we're doing that so that the cutter will come in and rough away, and then when it cuts the final cut, it won't be under load. And we'll cut a nice finish. In our maximum step over, we're going to reduce it to 0.03 because there's not very much room in this feature for the cutter to move around in. Then we're going to select multiple depths. And our multiple depths, we want to mirror what we've been doing before. So we did 0.03 for our maximum roughing step. And then we'll do one finishing step over at the bottom. And that step over will be 0.05. We'll just mirror what we did in this box. Approach along wall is fine. And we are going to finish only at the final depth, as we have a cutter that's long enough. And we're going to use even step downs. And we want to rough the final. The rest of these boxes will not matter because of the type of geometry we selected. You want to make sure you have this smoothing selected, and you want 4/10 in that box there. That's going to give us a nice curvature. Okay, we're going to go to linking tab. We're going to leave these all at default. We're going to set our horizontal lead in at 0.01. We're going to set our lead in distance as 0.01. So we're doing that because there's not a lot of room for a lead in. Okay, and our vertical lead in is going to be 0. And we want to make sure that these two boxes are selected, lead out, and to have a lead out and have it the same length as the lead in. We're going to hit OK. And so we get 1, 2, 3, 4 roughing, 5 roughing cuts going down, and then we step over 5 thousandths and we do a finishing cut. The green arcs are our lead ins for our roughing and our finishing passes. Okay. Now we want to finish the exterior of the part. Now we like most of the parameters on that one. We can do the same thing. Let's highlight this last routine, and we're going to do a copy, paste. Alright, so here's our contour number 3. We're going to go edit. We're going to leave all of this at default. The thing that changes is the geometry. So we clear out the geometry. Now we're selecting the exterior of the part. You want to make sure that the arrow is on the outside of that profile. And we're going to the next tab. So on the heights tab, we're going to leave most of this at default, except for our top height. Our top height is going to be selected. So we're going to pick selection. And the top of our cut is going to be the top of this flange area. We've already roughed away all the material, so all we need to do is cut between that face and the selected contour, which is the bottom. So we've now moved the start of our cut to down here. And then we're going to go to selected contour as our depth, which is outside radius, but we're going to leave 10 thousandths at the bottom. And what that will do is leave a little bit of flash to hold the part to the surrounding material, and we'll cut that material off to remove the part from the stock. Now we'll move on to the passes tab. We're going to go to our passes. Pretty much all of this is going to stay at default. And our roughing passes on the sides, we're just going to have 1. We can bump our roughing pass back up to 60 thousandths because we have plenty of room on the outside of the part. We're going to do 1 roughing pass. And on our multiple depths, we're going to do a maximum roughing of 0.03 with 1 finishing pass at the bottom, and that'll be at 5 thousandths. Okay. All of our other parameters, we're going to pretty much just stay the same. Smoothing there. Now we're going to go on to the linking tab. We're going to leave everything on the top as default, and we're going to leave a lead in. We're going to do a horizontal lead in of radius, we can go ahead and bump this back up to something larger because we're on the exterior of the part, and our linear lead-in distance as well. We don't want a vertical lead-in on this type of cut, and these should be all at default. We select OK. Okay, so we have our plunge out here off the material, and then we have a horizontal lead-in going into a radius, and we have a couple roughing passes. We're leaving 10 thousandths on the bottom, a very small amount of material. Okay, we're done. Now, we have several of these contours. When you have several of the same type of feature after another with the same tool, I like to go in and change the name so it's a little more descriptive. This name, whatever is here, will show up in the code and on the setup sheets. So we're going to instead of having this, we'll leave the 2D adaptive because that's roughing. But what is this actually cutting? So we're going to call this a 2D contour of boss. And we'll change the name of this, the 2D contour of bore. And we'll change the name of this last one to 2D contour profile. How about OD, outside diameter profile? Now we know what these are actually machining, and if you have to reorder things, it gives you a better idea of what to look for. Alright, we need to save. We're going to save and hit OK. And again, this overlays on your model file. You're just in a different workspace. We're using the same model file name. And now we will first simulate to see what we've done. Drag this off to the side. And we're watching for mistakes where we might be plunging into material where material is too much. So let's hit OK here. We got our stock sim shown, and we're going to hit play. So we come in. It's roughing around the shape. Now it's going to go over and it's going to rough another level. Okay, and now it's going to come down and cut the center to the same level, and now it's going around the outside perimeter. Again, this is leaving material for the next routine to take off. And it's going to go back to that center bore and do that final depth. Now it's coming over and it's doing the 2D contour to finish the boss. And it's cut right down to the geometry. You notice those cuts are smoother. And now it's doing the roughing cut on the inside of the bore. Cut all the way through the part and done a finish cut. Now it's coming out to the outside. Now I'm going to point out something. We just gouged. We gouged here and here, and that's because our lead-in radius is starting our cut farther out than what we've roughed. We probably don't want to do that. That could break an end mill. So what we're going to do is go in and adjust our code or programming to eliminate these two divots here, shown in purple on the sidewalls. So the parameter we're going to adjust will most likely be this linear lead-in, and we can adjust this radial lead-in by making them both smaller. So that's what we've learned in our simulation. So let's go back and fix that. That routine was our contour for the outside diameter. So we're going to go to Edit, right click, Edit, and that parameter should be on the last tab, which is the linking tab. So our horizontal lead-in, we bumped it up to 60 thousandths. That was a mistake. Let's set that at 30, and let's put the linear lead-in at 20 thousandths. Now we'll go back and simulate it and see if that does the trick. Now what I think the key is that the center line didn't pass the black line that we drew for the stock. Alright, so let's go back to simulate. Pick on simulate. I'm going to bump the speed of the simulation up a little bit. There we go, that looks better. So now our plunge, when it's coming straight down, isn't hitting this mass of material here. It's within what we've roughed. Okay, so we've simulated it, we've looked for problems, we found one and we fixed it. Now let's make sure we save again. Now the next step is to run a setup sheet. Now we're going to run a setup sheet before we post-process because we're going to look for some red flags. So press setup sheet, tell it where you want to save it, and your setup sheet should look something like this. Now something to think about when you're making the setup sheets is have your part zoomed in and have the setup here selected so that you can see what where the stock is and the origin for the setup operator. I hadn't done that on this setup sheet, so that's a bit of a mistake. Let's do it again, and let's zoom in a little more so that the graphic's going to be bigger. Select the folder it's going to go into. Okay, and so that shows your origin, shows the stock material for the operator. Alright, so what we're going to look for is red flags. Now we thought we programmed everything at 5,000 RPM, so let's make sure that our maximum RPM is 5,000. That looks correct. Now we're going to look at our feed rate. Are we going over 17 inches a minute? No. The maximum feed rate in the entire program is 16.5. Okay, so those are good flags to look for. Now minimum Z, our minimum Z is the thickness of our material, so that looks good. Our maximum Z is set at 60,000 above the part. That looks good. And if we scroll down, now we can look at the setup sheet and it'll say, okay, we're doing a 2D adaptive, we got our contour of the boss, we have our contour of the bore, and we have our 2D OD profile. So try to keep your names about that length or shorter. That way they show up on the setup sheet as well. Okay, we're done with that. And now we're ready to post-process. You select the machine that you're going to send it to, which ours is going to be a Haas. Your program number should populate, just like in the setup. And your program comment is operation 1. We're going to hit post-process. And you need to save it to a destination on your drive. The post-process file will be .nc. It's really a text file, so if you change the extension to txt, you could open it in any text editor. You're going to hit save and OK. And here's the code. We're only using one tool, so it only lists the one tool, tool 17, with a diameter of 0.175. We got our 2D adaptive 1. We keep scrolling down. We should see, even though it's the same cutter, we should see a note eventually. See a note where it starts contouring the boss And here's where it does the contour of the bore. And here's where it cuts the OD profile and into program. Okay. A lot of code that Fusion saved you from having to do by hand. So follow your instructions for the assignment on what to turn in. It'll be noted in Canvas. Hope this video helped you, and we'll see you on the next one.